Welcome back, students. Today is Q&A session 6 from the chapter of friction, and this is a very good question which I have taken from one of my reference books. This is the question, and the question is: a block P is placed on a smooth horizontal surface. Another, it is placed on a smooth horizontal surface means that is the coefficient of friction is 0. So there is another block of the same mass m which is placed over it. It means that the mass of this block is m. The mass of this block is also m. The block P is pulled by a force F as it is shown in this figure. The blocks, that is both the blocks, they move by a distance a. The block Q oscillates without slip when the force is released. It is pulled by a force in this direction. The block P is pulled by a force in this direction. It is connected to this spring which is having a spring constant of kx. Which is having a spring constant of k. And so when this force is withdrawn, then what happens that this block Q, it oscillates without slip. So in this case, one more thing here, the coefficient of friction between the surface of this block Q and this block P is mu s. So we have to find the maximum value of frictional force between the block. Here we have been given 4 options here, so we have to find the correct one. So see, in this case, the spring constant of this force is k. So when I am applying a force in this direction, a restoring force, that is the spring force, will be acting in this direction. Okay? The spring force, or you can say the restoring force, will act in this direction. Now when I have applied a force F in this direction, both these blocks means they have shifted by a distance a. And when this force is withdrawn, then in that case this block Q, it oscillates without slip. So Q will oscillate. Q will oscillate without slip. When the acceleration of Q is equal to the acceleration of block P. Second thing, since the block Q is oscillating without slip, so in this case the maximum acceleration will be equal to omega square x. This is the maximum in acceleration in the case of a simple harmonic motion. So since Q is oscillating without slip, then it is a case of a simple harmonic motion, and in that case the maximum acceleration is equal to omega square x, where omega is the angular frequency, and this is given by under root of, in this case it will be k divided by 2m. Okay, where k is the spring constant. So now the maximum acceleration is equal to omega square x, which is equal to omega square a, because x is the displacement. So in this case the displacement is a. So now here also the angular frequency, the maximum acceleration is equal to omega square x, which is equal to omega square a, where omega is the angular frequency, which is given by under root k divided by 2m. So now the maximum acceleration will be equal to omega square will be equal to k upon 2m into a. So this is the maximum acceleration. this is the value of the maximum acceleration, which is equal to Ka divided by 2m. Now we have to find the maximum value of frictional force between the two blocks. Now here, this is the maximum acceleration. So the maximum frictional force, will be equal to m into this maximum acceleration, which I am just writing here as m. I am writing here as a m. That is the maximum acceleration. So we can write it down here. Yeah. So the maximum acceleration, the maximum force, the maximum frictional force. The maximum frictional force is equal to m into am. Am is what? It is the maximum acceleration, and so we can write it here as m into am. Am is equal to am is equal to Ka divided by 2m. So this will be equal to m, and m will get cancelled out. So this will be equal to Ka upon 2. So the maximum frictional force between these two blocks will be equal to Ka upon 2. So the correct option is A. Okay. So this is how this question has to be done. Here we have applied two important things. First thing is that the maximum acceleration in case of a simple harmonic motion is equal to the maximum acceleration in the case of a simple harmonic motion is equal to omega square x, where x is the displacement and omega is the angular frequency. Now in this case, the angular frequency is equal to k upon 2m. So and here x, that is the displacement, is equal to a. So substituting the value of x as a and putting the value of omega square from this equation in this equation, that is let us say this is equation number 1 and this is equation number 2. So substituting the value of this omega from this equation number 2 in equation number 1 and putting the value of x, which is equal to a, we have got the value of maximum acceleration as Ka divided by 2m. And so the maximum value of this frictional force will be equal to, that is mass into acceleration, that is m into this maximum acceleration, so m into Ka divided by 2m, which is equal to Ka upon 2. So in this way we have found the value of the maximum value of the frictional force. So here the most important thing which you have to remember is these 2 points, that is the maximum acceleration in the case of simple harmonic motion is equal to omega square x, where x is the displacement and omega in this case was equal to under root k by 2m, where k was the spring constant. Okay, so thank you very much for joining this session, and in the next session I will be coming up with a few more questions pertaining to the same topic. Okay, so till then, have a nice day.